Good morning, beautiful people. I got a request from my student. Funa ndimubonise Norton's theorem. Guys, Norton's theorem is simple. It's exactly like Thevenin's theorem. If you haven't watched that video, please watch it. Yeah, but it's exactly like that. You take any linear network, you can reduce any linear network into this circuit in draw up. With Thevenin yena uthetha ge voltage source, yabo, ne Thevenin resistance in series. But uNorton yena uthetha nge-current source ne Thevenin resistance in parallel. Then lo R lona, it's our resistance of interest, is the one that we are questioned on. Current. So I'm gonna do this question when you're doing in Norton's theorem, you can reduce any circuit into this Norton's equivalent circuit. This is Norton's equivalent circuit. And it is Thevenin. Okay, Norton's equivalent. Equivalent circuit. Okay, guys, this was the question that was asked by the student to do there. Using Norton's theorem, okay, we're gonna apply this theorem now. Okay, calculate the current flowing through the 11,2 ohm resistor. The 11,2 ohm resistor is the load resistor, you can see now. So basically that is our resistor of interest. Okay. Also calculate the voltage drop across this resistor. Same thing that we're doing with Thevenin. And if you go back to the video I posted on superposition and Thevenin's theorem, we're gonna look at the resistor of interest, the one that they are questioning us on, which is this one. And we're gonna remove it from our circuit. Okay, let us remove it from our circuit. $20 volts. Okay. R1. Okay. Then okay. Okay. So we said we're gonna remove it. So let's say this is terminal A. This is terminal B. Once we remove it, guys, we don't leave it open like that. We put an ammeter. We replace it with an ammeter. Okay. What you should know, guys, the important thing you should know that the resistance of an ammeter is theoretically 0 ohms. Okay, so we have R1, which is 20 ohms. We have R2, which is 12 ohms. Then we have R3, which is 8 ohms. Guys, what is happening up? Resistance ammeter ntengubani goes 0 ohms. If you go back to the video here, Thevenin, theorem. I told you that if you connect an ammeter, if you connect a short with a resistance, the total resistance yellow branch man was 0. So this is what is happening up. Up, we're gonna disregard this resistance because it is connected with an ammeter that is having a 0 ohm resistance. For example, if I connect this 8 ohm resistor with a short, which is 0 ohms, 8 ohms, can value overall total circuit upper yafana noba it's RT is equals to 8 times 0, 8 plus 0, that is gonna be 0 ohms. Guys, whenever you connect any resistance, noba resistance ingangu trillion ohms, as long as you connect it in parallel with a short, total resistance was 0. Yeah, so basically what is happening, this is my source now. This is my source of current, like 20 volts. Let's remove this resistor. Let's remove this resistor. Got 3 ohms because if I know because it is shorted out by ammeter lena. Okay, now I need to calculate the current that is flowing through this ammeter, of which is the current that is flowing through this ammeter is equals to IR2. So basically, why am I calculating the current flowing in the ammeter? That is gonna give us in Newton's current. Remember, in Newton's equivalent circuit, it is in Newton's current. So to calculate in Newton's current, this is the procedure. You remove the resistance of interest, you replace it with an ammeter. Okay? Where with Thevenin we removed it and we replaced it with an open circuit. But with Norton we replace it with an ammeter. Okay. OIR2 is equals to I Norton, because it is the current flow up is the same as the current flow through ammeter. How do we calculate II2? We know that this is in parallel with this, so they are this resistor is receiving 20 volts, and even this resistor is also receiving 20 volts. Okay, so we can say current through R2 is equals to VT over R2, which is 20 over 12. Let us punch that. Okay. 20 over 12. That is gonna give us 1,667. We have calculated in Norton's current. Hey guys, okay, now that we calculated in Norton's current, we must determine in Norton's resistance. Masibuyisele la resistor ke lebe siyikhophile. Yabo, because now we're gonna do something different. We're gonna do something different. Let us we go now to calculate OR Thevenin. Yeah, not R Thevenin, OR Newton. We remove the ammeter. Okay, we remove the ammeter. Okay, we're removing the ammeter, and we replace it with an ohm meter. Okay, the ohm meter, guys, I find again ne ammeter. Ohmmeter has a high value of resistance. Okay, so it doesn't short out obani or R3, which is equals to 8 ohms. Okay, once you remove mose ammeter, once you remove ammeter ufake ohmmeter, you're gonna short circuit in a voltage source. Any voltage source ekhoyo ku circuit, you're gonna short circuit. Let us short circuit. Yabo si short circuit ilela 12 volts voltage source, of which is siyabona ke ngoku le short circuit siyibekileyo ngoku is in parallel no R2. That means iyafana nobo R2 akekho, yabo, because it's short circuited by this branch where bekukhona a voltage source. Okay, so we can safely remove it. Okay, so now we have to calculate a total resistance P up and a total resistance that is appearing across this ohmmeter, which is we have R3 no R2 in parallel. So that is going to give us a Thevenin resistance, which is R2 times R3 over R2 plus R3. That is going to be 12 times 8 over 12 plus 8. That is going to be, so let me punch that, 12 times 8 over 12 plus 8. That is going to be 4,8. Now we have everything. We have we have Norton's resistance, we have Norton's current. Now we can draw the equivalent circuit here. Okay, we can draw equivalent circuit. There we go. Newton's resistance is in parallel, okay, with a current source. That is Newton's theorem. Okay. Sorry. There we go. Then we know this is our current source. Newton's current we have calculated as 1,667. Then this is Newton's resistance. Then ke ngoku singabuyisela ke ngoku that resistor of interest back up kwi-equivalent circuit. Okay, siyayibuyisela. Okay, RL, which is 11,2 ohms. Okay, meaning which ke ngoku thina sifuna a current that is flowing through I load, we can use a current divider rule. I load, because this Norton's resistance is in parallel with R load, we get I load as equals to R Newton over R Newton plus R load times I Newton, which is gonna be equals to R Newton 4,8. Sorry, 4,8 plus 11,2 times 1,667. Different I load. Okay, that is gonna be 4,8 over 4,8 plus 11,2 times 1,667. That is gonna be answer here to 0,5001 amps. Now that we have calculated I load, bafuna V load, UV load is therefore equals to I load times R load, which is 0,5001 times R load 11,2. So UV load is equals to 0.50 times 11,2. That is gonna be 5,601 volts. Niyabona you guys, i-equivalent circuit yiyo esinceda uba sifumane i-final answer. Yabo, whether it's current or voltage across lo resistor siyifunayo. Same as we did Newton's theorem. So guys, please like and subscribe to my channel. Thank you.